Okay, let us discuss this problem. This is something related to dipole moment. So let us discuss this problem is 16.69. So you have something like this. So let us copy this one. Aniline, NH2 here you have. And then you have bromobenzene. So this is bromobenzene. So you have here double bond. So benzene and this is bromo groups. So you have bromobenzene, and then you have something like aniline, and that also contains a bromo group. So NH2 and there is a bromo group. So you can say para-bromo-aniline. So this is a para-bromine. In each case dipole moment is given. For this molecule dipole moment is 1.53 dy. In this case dipole moment is given. This is 1.52 dy. In this case dipole moment is given 2.91 dy. So what is the question? You have three molecules, and these three molecules are basically polar molecules, and that's why you have a dipole moment. In first case dipole moment is 1.53 dy. In second case 1.52. In third case 2.91. So these are the magnitude of dipole moment. So we does not know the direction. So these are only magnitude of dipole moment. So magnitude is given. Magnitude is given. Are you getting? So this is the dipole moment magnitude is given to you. Now the question says use your knowledge of directing effect. So you see what is the knowledge of directing effect. NH2 is basically give electron to the ring, and Br give as well as take both. So for reactivity we consider minus I effect. For orientation we consider plus I effect. So let us consider here minus I effect. We will see soon. So this is, so if I assume Br as a minus I effect. Now question, let us listen. Use your knowledge of directing effect, that is effect of plus R or minus I or plus R, even if you have, then we'll discuss. So use your knowledge of directing effect along with the following data to deduce the dipole moment in the aniline and bromobenzene. Dipole moment in aniline and bromobenzene. Okay, so what the question is, you have to decide what is the direction of dipole moment in aniline and what is the direction of dipole moment in benzene. This means we have a question something like this. I have a dipole moment in NH2 and I have a dipole moment in bromobenzene, because magnitude is given to you. Now what will be the direction? Either two options we have, either dipole moment in this case aniline is this side or this side. In this case also I have two options, either it can be this side or it can be this side. Now see, nitrogen, if you see, nitrogen gives electron to the benzene ring. So if you see nitrogen gives electron to the benzene ring, this means there is some positive charge on nitrogen. So in this case it looks like direction of dipole moment is something like this, that the positive center you have this side and negative center something like this side. So you will have a positive center this side and negative center this side. So direction of dipole moment will be this in case of aniline. Now let us discuss bromobenzene. So let me rub this one. So I don't have a direction of dipole moment. This is basically wrong. Now if I consider this one. Now if you see, if bromobenzene has a direction of dipole moment on this side, so what will have the effective if I take this molecule? Now NH2 I have here, let us say, and Br I have here, basically both are in para position. Now I have decided for NH2 positive charge from nitrogen, direction of dipole moment is this, because I have decided in aniline nitrogen is a positive center. So if nitrogen is a positive center, so this is the direction of dipole moment, and the value is 1.53 dy. You see in your copy, so this is 1.53 dy. Now you see, for this molecule, what is the total dipole moment? You can see here, this is 2.91. Now I have an idea. If I have dipole moment due to bromine in this direction, so in that case resultant dipole moment will be what? 1.53 minus 1.52, because if you have a bromine group here, 1.5 to this side, in that case the resultant will be only 0, approximately 0.01, 1.53 this side, 1.5 to this side. So you will have 0.01 this side, but that is not the actual case. Actually the dipole moment of this molecule is 2.91. This means I have a good idea. This means the dipole moment due to bromine has to be in this direction, and the magnitude will be 1.52 dBi. Are you getting? This is 1.53 dBi. If you add these two vectors, so it will becomes around 3.05. So 112 and 50, 50 and 05, so 3.05, and that is actually the case. That is the dipole moment is around 2.9. That is actually the 3. So this is an experimental fact. So this means now I know what will be the direction of dipole moment in bromobenzene. So bromobenzene, direction of dipole moment, it will go towards the bromine side. So this means this is wrong. So electron is taken from benzene ring and this is going towards bromine side. Now if I see this experimental effect, I am very much sure bromine is basically deactivating the ring, because this is taking the electron from benzene ring. So this is deactivating. So for bromine, if I reactivity consider, if I dipole moment consider, I have to consider minus I effect. If I consider minus I effect, then only I can say these electrons from the ring is coming towards benzene side. So this is a pretty good problem. You see, if you have copied, not copied, let us copy this one and then we'll discuss again. Okay, let us discuss in short. So you see what we have. We have three molecules, aniline, bromobenzene and para-bromoaniline. Dipole moment of this molecule is given. Dipole moment of this molecule is also. This is experimental fact. So these dipole moments are found from experiment. Now what is my target is to decide what is the direction of dipole moment in this one and what is the direction of dipole moment in this one. Now if you see the magnitude, this plus this, it gives approximate focus to this. This suggests me one very good thing. Dipole moment in this molecule and dipole moment in this molecule must have in the same direction. Are you getting it or not? They cannot have opposite direction. They must have the same direction. Now you know for aniline, because nitrogen gives electrons, so nitrogen will have a positive charge in one resonating structure. If you're not convinced, I can show you. So you see, in one resonating structure, you can write. So if this lone pair goes here, this goes here. So you will have double bond nitrogen H, and then you have carbon. So here you have a minus charge. So this is your plus charge on nitrogen. So you can clearly see there is a minus charge in the benzene ring. So this is it. The direction of dipole moment is something like this. So I know in bromobenzene, in aniline, the direction of dipole moment is from nitrogen to benzene ring. This suggests me in bromobenzene also the direction of dipole moment should be from bromine to ring, and that I am saying this should be, so this should be bromine, no, so this should be of course this is nitrogen to, so you see in this case the direction of dipole moment is from nitrogen, so this in this case from ring to bromine, and that's why I can add. So in this case you will have a direction from ring to towards bromine side. Are you getting or not? So in this case you have from nitrogen to benzene side. In this case you will have from benzene to bromine side. So that you can add. This is only possible only if you take electron from benzene to bromine and then you have a direction from benzene to bromine. Are you getting or not? So let us finish this one and then we'll go for the next problem. So you can clearly say bromobenzene, bromine is acting as a deactivator, that is electron taker, and in NH2, NH2 is acting as electron giver. So what is happening? Somebody is electron giving, like NH2 is electron giving, something like this. NH2 is electron giving, and bromine is electron taking. So what is happening? From here electron is going, once again from here electron is going. So basically you are adding two dipole moments. So here is a mu1, here is a mu2. So finally the resultant dipole moment is mu1 plus mu2, nothing. So simple. Are you getting or not? So this is the only thing we are, this is your ring. So your NH2 is giving the electron to the benzene ring and bromine is taking electron from the benzene ring. So I can add the final dipole moment. We'll go for the next problem. We have taken so much time in this problem. Okay, let us copy fast, those who have not copied. Slowly we will increase the speed also because these days competition are so fast. Speed matters a lot. So in the same amount of time, if somebody gathers more information and you gather less information in the same amount of time, then he will do better in the exam, because everything is information. If you have more information, you can do well in the exam. If you have less information, you can't do better in the exam. So it's a exam of information. If you have more information, you will do well. So competition is also not only how much you read. Competition is also in the same amount of time how much concentrated you read. You have to read also. This is not sufficient only you are reading 10 hours. That is not sufficient. How much concentration in your reading, how much you are getting from that time, that is also important. You have to read and you have to think also. You have to be 100% concentrated, and then you will get into the exam. And that is the competition all about. We'll go for the next problem.